We were discussing about organic chemistry. We already discussed about the nomenclature of organic compounds having various functional group, and now there is a small topic left out, that is bond fission in organic chemistry. So if you take any chemical reaction in organic chemistry, it is supposed to happen in this particular, that is a substrate reacts with a reagent to give an intermediate, and that intermediate will get converted to a product. For the time being, we take the reaction, that is substrate reacts with reagent to give product. So I can make it into the next level, that is, we can take like this a nucleophile having a negative charge reacts with an electrophile to give a product where there is a bond between a nucleophile and electrophile. That's how it happens. So come back to this. A substrate means, what is a substrate? The substrate means it's the part of the organic compound which contribute most of the carbon atom in the organic compound. Means the part of the product getting formed where more number of carbon atoms are provided. But still, that also will be having a charge. And the reagent, generally, there are three types of reagent. One is what we call nucleophile having a negative charge, or electrophile, or it is called free radical. Free radical is not having a charge, but it is specialized with a odd electron, a single electron. So a substrate reacts with a reagent to give a product. It could be bit next level. You can write a nucleophile reacts with an electrophile to give an organic compound or a product which is having a bond between a nucleophile and electrophile. So the question over here is, how this nucleophile and electrophiles are generated? It is through fission. Fission could be told like bond fission. Now, what do you mean by bond fission? Suppose if you take a molecule could be formed between two atoms having identical electronegativity. For example, A combined with another A. Another example is A combined with B. This is with different electronegativity. So what happens is, when they come to a particular situation where they are supposed to depart, it can have, suppose if you take this two, this is the pair of electron that makes them together. So if they are moving away from each other, what will happen? Like suppose if there is some chocolate kept between two persons, so they are all sitting at the middle. So immediately there is an option like they are equal in strength. These two are equal in strength and the chocolate is kept in the middle. So what will happen? Because both of them are having equal strength, one will not snatch away this chocolate. So what do? They will distribute it equally. So these two atoms are equal in power. So they will distribute it equally. So what happens? This is a pair of electron having, means two electrons are there. Each electron will be taken away by both the A. So it is represented like this. See the arrow bar, it is having only one side like this. So there will be the formation of A dot and here also A dot. This is how it is formed. So what has happened is, the equal distribution of the electrons in the pair happened. So equal distribution. So finally what has happened? Both of them have got a single electron. So both of them are having odd number of electrons. And we have found that the reaction happens quite fast. And another point is it can happen in presence of heat or light. Then this is, if it is happening in presence of heat, we call it as thermolysis. There is a term that is olysis. Olysis means breaking, fission. So heat, thermolysis or photolysis. So here what has happened is there is a pair of electrons in between these two atoms, that's why they are together. That is what we call bond. A bond is having a pair of electrons and the pair of electrons is divided equally. So there will be the formation of a species which is having odd number of electrons is what we call free radicals. Free radicals are getting formed. When the distribution, during the breakage of time, the electrons are distributed equally. So this is called homolysis. Homolysis means the equal distribution of electron happened. The best example for this fission is chlorine molecule dissociating to two chlorine free radicals in presence of sunlight. Photolysis of photofission of chlorine. So how it happens is just like in the same mode, the Cl and Cl will get broken to give two chlorine free radicals. That's how it happens. And the best example means there you will come across there is a peroxide effect. Peroxide effect is due to the presence of this free radical. And that free radical is C6H5 COO. The same will repeat OCO C6H5. The fission happens over here, and you could understand it from here. And the fission happens between two equal parts. Means they are equal in electronegativity. So one cannot snatch the pair of electrons. That's why it goes for homolysis. So this is what about homolysis. Homolysis will lead to the formation of free radicals. The best example is chlorine free radical, and this is called peroxide free radical. Benzoyl peroxide free radical. This is what the free radical, there will be a single electron over here. We'll talk about if there is a molecule which is formed out of having different, the atoms or the elements having different electronegativity. AB. So if you look at the nomenclature, suppose if you write the name of the compound, the first the metal, the first atom will be having more electropositivity and this will be having less electropositivity, electronegativity. So, if you go for the holysis or the fission or the breakage of the bond, will not happen uniformly. Like the pair of electron will not be shared in between in a uniform mode. It will go for unequal distribution. So, A, B, being having more electronegativity for B goes like this. Then what will happen? A was already having a single electron, it is shared in between A and B, that is taken away by B, so it will be losing a single electron. So its charge will be A plus B minus. So I was asking a question, how the nucleophile and electrophiles are generated. This is how it is generated, and this fission is called heterolysis, unequal distribution of shared pair of electrons. Heterolysis, A plus and B minus. Here there is a deficiency of electron cloud, there is excess of electron density. And when there is deficiency of electron density, it will be seeking for electrons. When they are seeking for electrons, we call them as electrophile. Whereas here there is excess of electron density. When there is excess of electron density, we say they have excess of electron density. When they are having excess of electron density, they are seeking to release or remove or get away from the electrons. And when they are get away from the electrons, it could be told like in a different way. They would like to attract a positive charge or a nucleus. They have the affection for nucleus. So we call them as nucleophile. So when there is a molecule having atoms of different electronegativity, when they go for fission, the pair of electron will be completely transferred to the more electronegative atom. That is what we call heterolysis. Heterolysis will lead to the formation of a species which is having deficiency in electron density is called electrophile, and excess of electron density we call it as nucleophile. So what will happen? This bond will be polar. That's why it has broken like this. So there will be the generation of a nucleophile and an electrophile. You recall the initial picture I have written. An electrophile reacts with a nucleophile to give a bond. This is how the reaction happens. And we will take few examples. One of the examples is if you take CH3, Cl. So you know that there is a bond between carbon and chlorine. Which one will have more electronegativity? Carbon or chlorine? Definitely, chlorine will have more electronegativity. So what will happen when there is a possibility of fission of this bond? There will be a formation of CH3 plus Cl minus. And here this is electrophile and this is nucleophile. And one more thing is, when there is a electrophile which is formed out of a species which is having carbon atom, we call it as carbocation, or we call it as carbonium ion. Carbocation or carbonium ion. We'll take another example, that is MgCH3. You must have heard of Grignard reagent. That is a carbon atom combined with a metal. Could be lithium, sodium, magnesium. So this is Grignard metal carbons. Its name is magnesium, methyl magnesium. So here what happens is there is a bond between magnesium and CH3. Actually this is not exactly a covalent bond, it is highly polar bond. So when there is a fission, we can take lithium, methyl lithium or lithium medium. So here what happens? CH3, because this lithium is having more electropositivity, then the fission happens like this. There will be the formation of CH3 minus plus lithium plus. And here this is the electrophile and this is the nucleophile. And the CH3 minus is a nucleophile having a carbon atom. So when there is a nucleophile having a carbon atom, it has got a special name. That special name is carbanion. So carbanion is a nucleophile of having many carbon atoms. Carbanion. Best example is methyl carbanion. This is methyl carbocation. So the carbanion, carbocation. So what is carbocation? It is basically an electrophile. What is carbanion? It is basically a nucleophile. So this nucleophile or this electrophile or the free radical which you have seen the this one will react in the role of reagent in order to give